Welcome to Physical View. Today, let's talk about data types in Java programming. Java is a computer language, and we must provide or receive data in a way that the language understands. Data types are classified into primitive and non-primitive categories with further subclassifications within these. So, what exactly are data types? Why do we classify data? To understand this, let's consider a simple example. Take an object, anything at all, for example, a mobile phone. This is a solid substance. The mobile phone is an object. In Java, we refer to it as a variable. In this specific example, let's call the variable for the mobile phone X. Now, let's take a variable Y for a liter of milk. Here, Y is a liquid substance. When you purchase the mobile X, it's delivered in a box. When you buy Y, it's delivered in a bottle or packet. Similarly, let's take cooking gas as variable Z, which is a gaseous substance. Variable Z would be delivered in a leak-proof cylinder. In this way, the various types of data we provide to a computer must be presented in different formats. The classification of data types tells us what kind of data we intend to store in the computer, which is why data is divided. Primarily, data types are divided into primitive and non-primitive types. The primitive types include numeric, Boolean, and character types, while the non-primitive types consist of arrays, collections, interfaces, and classes. First, let's understand numeric data types. Numeric data consists of numbers and is further classified into integer types and floating or decimal types. For example, if variable X is 50, that's an integer, whereas 1.2 would be a decimal. We use integers to represent whole numbers, like there are 50 books, and decimals for fractional values, like the weight is 1.5 kilograms. We typically calculate currency in decimal formats. For instance, if your bank balance is 523 rupees and 56 paise, you would use the decimal data type to represent it as 523.56. Integer and decimal types are further classified. Integers are divided into byte, short, int, and long. Decimals are classified as float and double. These classifications help us manage data size effectively. For instance, when ordering 50 books, the larger box is used for delivery, while a smaller box suffices for just 10 books. Similarly, we select byte, short, int, long, float, and double based on data size. Now, let's understand computer data units. 1 bit equal to 1 binary digit, the smallest unit of data. 1 nibble equal to 4 bits, or 1 byte equal to 8 bits. 1 kilobyte KB equal to 1024 bytes. 1 megabyte MB equal to 1024 kilobytes. 1 gigabyte GB equal to 1024 megabytes. 1 terabyte TB equal to 1024 gigabytes. 1 petabyte PB equal to 1024 terabytes, used mainly in heavy data storage systems like company servers. Now, in integer data types, we can store 1 byte in a byte variable, 2 bytes in a short variable, or 4 bytes in an int variable, 8 bytes in a long variable. A byte can store values from -128 to 127. An integer can store values from -214 crores to 214 crores, but it can't hold a mobile number. For that, we need to use a long variable. In decimal types, a float can store 4 bytes and a double can store 8 bytes. The Boolean type has only 2 possible outcomes, yes or no, true or false. It is used in scenarios with limited outcomes like exam results. Below 35 is a fail and 35 or above is a pass. A Boolean can store one bit of data, just true or false. The character data type allows for ASCII values and can store letters and special characters. Characters must be stored as single quotes and can hold only one ASCII value. A character data type can store 2 bytes. Now, regarding non-primitive data types, they don't have a predefined size like primitive types. There are 4 types of non-primitive data: arrays, collections, interfaces, and classes. Arrays can store multiple types of data, but these must again be defined in primitive types. Similarly, collections can also hold multiple data types defined in primitive types. We will learn about interface and class in subsequent videos. Type. Thanks for watching. Subscribe for more Java tutorials and don't forget to hit the bell icon